Welcome. We're going to now build on our understanding in terms of basic numerical fluency to start our first operation, in this case, the operation of comparison. We generally don't think of comparison as being a mathematical operation. However, it's the foundation for everything that follows. To really do a good job with comparison, you do need to be sure of and develop the notion of sequencing, as we spoke about earlier. When we look at comparison, some of that language, first, second, from an ordinal sense will come into play. You'll also notice, however, that if we do our job right, comparison is simply a matter of visual recognition. And I think you will see that this turns out to be a much easier task than what you might have thought, particularly because we can now visualize from 0 through 9, and we have an understanding of what that would look like as it plays out across each of the place values.
In this video, we are going to make use of our numerical fluency ideas to show how we can get into our first operation. Now, by numerical fluency, we should be able to go fluently between the symbol, the spoken word for, and what it looks like using objects. This is, after all, the three-way interaction which defines numerical fluency. Now, if this is all we can do, what we have done so far is to successfully represent a number, in this case the number 4, in 3 different ways: in a written symbol, in a physical object, and in a verbal word. Let's pick another number, and the reason for this is if this is as far as we go, we can't do anything else, apart from look at it and say, my, what a wonderful 4 we've represented here. So let's imagine now that we are going to represent another number, in this case the number 5. We have used the symbol, we have used the verbal, and now we're going to represent it using our subtizable and chunking representations using the objects. Our first operation is going to be that of comparison, and we can get to comparison very easily. What we do is we ask ourselves the question, which is larger? And if you'll take a look at what we've got here, it's obvious which is larger. It's a simple visual recognition task. We can see that this is larger than this one. All that's left now is to build a record of this action. So I'm going to put a sheet of paper up here, and just in looking at what I'm seeing, just in looking at those physical shapes, I can tell that if I were to compare sizes, there's more over here than there is over here. So if I connect the dots, I get our old friend, the less than sign. So 4 is less than 5. You'll notice that our actions led to a very easy comparison here that's basically done with visual recognition. This is why we spent so much time developing this notion of what numbers look like. And because between being able to visualize numbers from 0 through 9 and understanding the base 10 place value system, we can represent numbers of any size. This basic process can play out regardless of the size or complexity of the number. You would simply represent one number, you would then represent the other, and you would ask yourself which is larger. And this is a task that's very, very easy to figure out just based on visual recognition. I also tried to share with you here a nice little trick to show how to generate some symbols. Let's imagine that we have these two objects being represented, and we just take a look at them, and we're interested in using a formal notation here to show which is relatively larger than the other. Well, as I look at these visually, I see that they both are relatively the same size. So if I play connect the dots here, I get my equal sign. If I change the problem yet again here, I can generate yet another symbol that we have to come to grips with. And in this case, you can probably guess where we're going, can't you? You can see as we set down our record of action strip here, compared to these two, there's more over here than there is over here. So we play connect the dots, and now we have a meaningful way of representing the basic results of what we would get in a comparison operation. We now know what it looks like for things to be equal. That's when we have the same amount on each side. We know what it's like for there to be more here than there is here, more here than there is here. And this symbolism can serve as a record of action for students as long as it's personally meaningful for them. What I find is that if you give students this way of understanding, these symbols become very, very easy for them to understand. And I think that on occasion, we sometimes forget that if a symbol is personally meaningful for a student, they can use it effectively. For example, I will bet there's a lot of young people who would be able to recognize this as the universal symbol for hamburger.